Makerspaces are found in universities for students to work on both their personal and class projects, as well as research. At these makerspaces, microcontrollers and expensive electronic equipment are in high demand, and makerspaces need to supply it. However, current issues with this are that this equipment and microcontrollers are often going missing or lost or damaged, with the makerspaces having to cover the cost. As an example, the Hive makerspace here at Georgia Tech has had to pay up to thousands of dollars in the past to restock missing equipment. So this discourages makerspaces from investing in microcontrollers and other equipment, which then in turn hurts student projects. The problem we seek to address is a lack of accountability, accurate tracking, and proper inventory management at university makerspaces.
So here is our solution. Here we have MIMS, our Makerspace Inventory Management System. And here's how it works. So we take our buzz card. Every student on campus has this. We go ahead and scan it, and it can log us into this website here. On this website, we have a kiosk that tracks our checked out and checked in items. Here, our checked out items show a couple options. I want an ATT Tiny 85. I'm going to add it to cart, and I can check it out. If students want more than one item, they can also select more than one item. So we check it out, and here our MIMS runs on a rotating table. This is done for three main reasons. One, so we can only have one camera, so we can minimize costs, and that there's only one single entry point of access. Once it spins to the correct location, I can pull this out, and a camera here will scan our data matrices as we pull it out. This will keep track of the items that are already in the drawer. Then, I can take an item out. As you can see, we have our data matrix here. And as we push it back in, it'll scan the items remaining in the drawer. This will indicate to the system what items I've checked out. Now, it will return to a starting position where I can no longer access the inside, unless I go ahead and check something out or check something in. The check-in process is basically the same, as it will spin, you place it in, and it'll notice the differences. And that's our solution.
MIMS has a variety of features that make it an attractive choice for makerspaces. One of the most important of these is the autonomy of the system, as you don't actually need a worker to be present while check-ins and checkouts are happening. All of that is done by the user themselves checking into the system, selecting which parts they want to check in or out, and then the system from there does everything on its own. This is extra helpful for makerspaces because this means that we can also have a log of every transaction automatically generated. On top of enabling makerspaces to track which users might be violating check-in or checkout policies, the makerspace also becomes equipped with trends in user data over time, right? So they can see what kinds of parts are being checked out, what kinds of parts aren't being checked out, and this will better inform their buying decisions of which parts to maybe invest in the future. Now, both the website and MIMS itself also have their own features that make them an attractive choice. For one, the website acts as an intuitive choice for users to interact with, select parts, whether they know the name or maybe just a photo of it. On the other hand, the single point of entry of MIMS is actually very nice for users to be able to know exactly where to look to find their parts compared to a lock-based system. Here, the part comes to them. Last of all, because of the decoupling of the website and MIMS itself, a makerspace could invest in multiple of these, and each one of these systems could work concurrently with a single website.